Welcome to a new episode of Green Dolphin Science.
Hello.
Today we're taking a deep dive into a study that explores something you might not immediately think about when you consider soil. Microplastics.
Right. We're sort of unpacking where they're coming from and, what their presence might actually signify.
And our listener, the learner, is keen on getting knowledge efficiently, those aha moments, without feeling buried in data.
Exactly. So we've sifted through this research pretty carefully to pull out the crucial insights, really focusing on the origins and, the potential implications of these microplastics in our soils.
Okay, so the main source for today is a scientific paper. It's called Accumulation of Microplastics in Soil After Long-Term Application of Biosolids and Atmospheric Deposition.
Yeah, it was published in Science of the Total Environment, and it's based on a, get this, 23-year study up in north central Washington state.
23 years. That's a long time.
It really is. So our mission basically is to understand how these microplastics are ending up in agricultural soil. The study looked at two main ways: using biosolids as fertilizer and stuff falling from the sky, atmospheric deposition.
Okay, prepare for some surprises, you said.
Yeah.
I'm intrigued. Let's start with biosolids. What exactly are they? And why should, someone eating food grown in soil care?
Good question. So biosolids are essentially a byproduct from treating wastewater. After sewage is treated and the water's cleaned up, this solid, nutrient-rich material is left behind.
Oh.
It's packed with things plants love, like nitrogen, phosphorus, carbon. That's why it's so useful as fertilizer.
Right, so it's kind of recycling nutrients. Makes sense.
It is, yeah. It's a form of resource recovery, and
Right.
It's actually really common. Back in 2019, I think over half the biosolids in the U.S. were applied to land, farming, other uses too.
Over half. Wow.
Yeah, it's a valuable nutrient source. And here's the catch, biosolids aren't just nutrients, they can contain other things too.
Uh-oh. Like what?
Well, depending on what goes down the drain, you can find metals, some pathogens, even tiny amounts of pharmaceuticals, nanoparticles, and crucially for us today, microplastics.
Microplastics in fertilizer. How on earth do they get concentrated there?
Think about everything small and plastic that goes into wastewater, like microbeads from cosmetics, though. Those are less common now, and especially tiny fibers breaking off clothes in the wash.
Right, synthetic fabrics?
Exactly. Wastewater treatment plants are designed to pull solids out of the water. And it turns out they're very good at grabbing these tiny plastic bits. The study mentioned over 90% of microbeads, for instance, end up in the sludge that becomes biosolids.
Over 90%. So when farmers spread these biosolids.
Yep. The microplastics are basically delivered directly to the soil along with all those helpful nutrients.
That's a very direct route. Now, the study looked at this for, as you said, 23 years. That's quite the long-term view. Tell us about that specific investigation.
Yeah, that long time frame is what makes it so valuable. The researchers worked at a no-till wheat farm, Douglas County, Washington.
No-till. Meaning they don't plow the soil?
Right. They leave the soil surface largely undisturbed. And at this particular farm, they'd been applying biosolids every other crop cycle since 1998.
Okay. And I assume they didn't just cover the whole farm. They must have had comparisons.
Oh, absolutely. That's key. They set up different plots. Some got low rates of biosolids, some medium, some high. And critically, they had a control plot that never received any biosolids at all.
Perfect. So they could really isolate the effect.
Exactly. It lets you compare directly over that long period.
So after 23 years, what did they find? I'm guessing more plastic in the soil that got the biosolids.
You guessed right. Significantly higher concentrations, actually. In the top layer, like the top 10 centimeters, the average in the treated plots was somewhere between 361 and 500 particles per kilogram of dry soil.
Okay. And the control plot, the one with no biosolids?
That had an average of just 117 particles per kilogram.
So 3 to 4 times higher in the treated plots. That's substantial.
Yeah.
Did it matter how much biosolids they added? Did the high-rate plots have way more plastic than the low-rate ones?
You'd think so, wouldn't you? But interestingly, no. They didn't find a statistically significant difference in the soil's microplastic concentration between the low, medium, and high application rates.
Huh, that's unexpected.
It is a bit strange, but they did measure the biosolids themselves and found they contained, on average, 12,200 microplastic particles per kilogram.
12,000. per kilo of fertilizer. That's a lot of plastic. What kind of plastic was it mostly?
The dominant types in the biosolids were polyurethane, PU, polyethylene, PE, and polyamide, PA, like nylon.
Okay.
And importantly, those same types were also the most common ones found in the soil samples from the treated plots. Pretty strong link there.
Yeah, it seems like clear evidence for biosolids being a pathway.
Yeah.
But the study title also mentioned atmospheric deposition. Are we seriously talking about plastic rain?
Sort of, yeah. Tiny particles carried by the wind and falling out, sometimes with rain, sometimes just dry. They actually measured this too.
Oh.
They set up collectors, basically rain gauges, around the site for about 2 years to capture whatever was falling out of the atmosphere.
Did they find plastic bits in there?
They did. They calculated that, on average, the atmosphere was depositing about 15 microplastic particles per kilogram of dry soil each year.
15 per year. Okay, compared to the hundreds already in the treated soil.
Yeah.
Sounds smaller.
While per year, yes. But remember the control plot. It had 117 particles per kilo after 23 years with no biosolids. Where did those come from?
The air, presumably.
Almost certainly. If you
Yeah.
figure 15 particles per year over 23 years, you get, well, quite a bit. It suggests the atmosphere could be responsible for maybe 20% or so of the total plastic found even in the biosolids treated plots over that whole time.
Wow. Okay, so maybe biosolids deliver a big dose at once, but the air is like this constant, slow drip of plastics onto the land.
That seems to be the picture, yeah. It's a significant background source, even out there. They also found something else kind of random.
Oh.
2 deflated birthday balloons just lying on the field site.
Balloons, huh?
Yeah, it's anecdotal, obviously, but it just highlights how larger plastic litter can also end up on farmland and then eventually break down into smaller pieces. They pointed out even 2 balloons could add a noticeable amount of plastic mass to the control plot in a single year.
Right. Another source to consider. So we've got biosolids in the atmosphere delivering these things. What specific materials did they ID in the soil itself using that fancy LDIR technique?
Right. Laser direct infrared imaging. Very precise. So in the biosolids, the top hits were polyurethane, polyethylene, and get this, alkyd varnish.
Varnish, like from paint.
Yeah.
In biosolids.
Yeah, maybe from paints or coatings washed down drains or industrial sources. It's interesting. In the soil samples, polyurethane and PE, water bottle plastic were common, along with polyamide. And in the atmospheric samples, mostly polyamide, think nylon fibers, plus polyurethane and polyethylene again. And across the board, the shapes were mainly fibers and fragments.
Fibers and fragments, so bits of clothes, broken pieces of larger stuff. Okay, let's bring it back to the learner. Why should someone care about this accumulation in farm soil? We're not eating dirt directly anyway.
True, but it matters. This research really drives home that microplastics are becoming part of our agricultural environment through very normal practices like fertilizing and just breathing the air, essentially. And while biosolids are genuinely beneficial for soil health and crop yields, providing needed nutrients, this study definitely flags up potential long-term environmental questions about the plastics they carry.
So there's a potential trade-off. Good nutrients,
Wow.
but also adding plastic.
That's one way to frame it, yeah. Understanding where these plastics come from, what types they are, it's really just step one. Step one in figuring out if they pose any risks. Risks to soil life, maybe to the crops themselves, or potentially moving up the food chain.
Right, so stepping back, we've got this picture of plastics entering soil directly via biosolids and also diffusely, constantly from the atmosphere.
Exactly. It's complex. Biosolids are useful nutrient recycling, but bring a plastic load. The atmosphere adds its own steady contribution, even in a relatively rural spot.
And here's something you mentioned earlier that really stuck with me. The study found less plastic in the soil after 23 years than they expected, based on how much was in the biosolids applied.
Yes, that was a really interesting point they made. The amount accumulated didn't quite match the total estimated input from the biosolids over 23 years.
So, where did the rest go? It didn't just vanish?
Well, they suspect wind might be a major factor. Remember, it's a no-till farm, so the biosolids and the plastics in them stay mostly on the surface. That makes them vulnerable to being picked up and blown away.
Blown away, so the microplastics could become airborne again.
That's the implication. Which raises a pretty big question. Where'd they end up next?
That kind of expands the whole issue, doesn't it? It's not just about oceans or even just soil anymore. It's about the land, the air.
Absolutely. It shows how interconnected everything is. What we put into our wastewater can circle back to our land and maybe even re-enter the air we breathe.
So for you, the learner, this deep dive gives a solid grounding in an environmental issue that maybe isn't always top of mind. It really highlights thinking about the whole life cycle of waste and these potential unintended side effects.
Definitely. And it leads to a final, maybe provocative thought for you to mull over.
Okay.
If atmospheric deposition is adding a measurable amount of microplastic, even in this fairly rural part of Washington, what does that suggest about places that are much more densely populated, more industrialized?
Right, where you'd expect more sources of airborne plastic particles.
Exactly. What could the levels be like there? And what might that mean for air quality, for urban farming, even for human health through inhalation in those areas? This study kind of cracks open a whole new door for thinking about that.